In this screencast video, we're going to try to understand substitution reactions. Substitution reactions are reactions that occur to alkanes and aromatics, and the substitution isn't like a mathematical substitution. Instead, it's like a substitution in sports where you're taking one atom out and replacing it with a different atom. So we have ethane has hydrogens as single bonds all around it. If I react fluorine to ethane and put it in ultraviolet light or light, the light provides the energy to break apart the bonds in the fluorine. So one of the fluorine atoms is going to be able to bond to this carbon, or any carbon in the alkane. The fluorine, when it bonds to this carbon, forces the hydrogen out, and that is going to now bond to the other fluorine. So we get hydrogen fluoride being produced, but I'm also going to have my fluoroethane. And fluoroethane is going to be a halogenated alkane, and this is one of the ways that we're able to make CFCs or HCFCs or hydrogenated HCFs, which are used as propellants and refrigerants. Now, this chemical reaction, you can see, is a substitution because we've substituted out a hydrogen and put in a fluorine. The net reaction is got all the same atoms at the beginning and at the end. If we had a molecule that had different hydrogens in it, so a different molecule, say like methylpropane, if I added chlorine to it in UV, then we're going to end up with the chlorine could bond to this carbon, and it would provide two different isomers. So my two different products could be CH3, CH3, Cl, CH3, if it bonded to the central carbon. So that's a 2-chloromethylpropane. Or it could bond to a terminal carbon, and it's going to produce CH3, CH3, CH2, Cl, and we're going to end up with 1-chloromethylpropane. And we can develop isomers doing this process. Now, this molecule, if I continued to do the reaction, will keep substituting chlorines with hydrogens. We won't ask you to do more than one substitution in a reaction, but you should understand that we can do this progressively to add more halogens to our alkane. So hopefully that helps you understand how substitution reactions can create halo alkanes, and hopefully this will make a few of the questions more clear in the textbook. And please understand that when it asks for all products, you need to consider if isomers are possible, because if there are isomers, then there's going to be more than one possible product.